Hello everyone, welcome back to my YouTube channel. This is Pragati from Steve English Media College of Engineering. I am currently studying in second sem. My topic is bisection methods and Lagrange inverse interpolations. Bisection method and Lagrange interpolation. In mathematics, numerical methods plays an essential role in computing an approximate solution to complex problem. This presentation seeks to explore two such numerical method, bisection method and Lagrange interpolation method. Now let me know about what is bisection method, definition, example and limitations. A numerical method that relatably bisects an interval and selects in a suitable in which a root must lies to find the roots of a real value function f of x. Example used to find the roots of real continuous functions such as trigonometric functions and polynomials. Limitations: convergence in slow and does not apply to complex functions with multiple roots or sharp. What is Lagrange's inverse interpolation? We see about definition and how to use it. Limitations: definition: numerical method used to find the value of an independent variable x that corresponds to the given value of the dependent variable y. How to use it: requires a table of value of a function f of x where you can interpolate it backwards by constructing a polynomial function using the x value as the dependent variable and the corresponding y value as the independent variable. Limitations: the interpolating polynomial can be unstable as oscillatory if the data is too closely spaced or has high frequency variation. Advantages and disadvantages of bisection method. Advantages: the bisection method is simple to implement and convenient to converge to a root. It is also relatively insensitive to the initial guess and can handle functions that are not different. Disadvantages of the bisection method: the bisection method can be slow to converge, especially for functions with multiple roots. It also requires that the function changes sign within the interval, which may not always be the case. What is Lagrange's inverse interpolation? We see about definition and how to use it. Limitations: definition: numerical method used to find the value of an independent variable x that corresponds to the given value of the dependent variable y. How to use it: requires a table of value of a function f of x where you can interpolate it backwards by constructing a polynomial function using the x value as the dependent variable and the corresponding y value as the independent variable. Limitations: the interpolating polynomial can be unstable as oscillatory if the data is too closely spaced or has high frequency variation. How does Lagrange's inverse interpolation works? Lagrange's inverse interpolation works by interrupting the inverse of the function using a polynomial. The roots of the interpolating polynomial is then used as a estimate for the roots of the original function. This process is repeated until the desired actually is achieved. Advantages of Lagrange's inverse interpolation. Lagrange's inverse interpolation can coverage factors than the bisection method. For certain functions, it is also more accurate for functions with multiple roots. Disadvantages of Lagrange's inverse interpolation. Lagrange's inverse interpolation can be more difficult to implement than the bisection method. It also requires that the function be invertible, which may not always be the case. Bisection method versus Lagrange's inverse interpolation method. Bisection method is good for Functions with intervals of uncertainty and unknown roots. Lagrange's inverse interpolation is better for functions where the y value with a corresponding x value are unknown or the inverse of a function is required. Both methods have limitations and should be used with caution depending on the type of function being approximated. Conclusion for both bisection method and Lagrange's inverse interpolation. Bisection method is simple and initiative method with good accuracy for solving real value functions, and Lagrange's inverse interpolation, it is the powerful and efficient for solving functions where the value are dependent and independent variable as unknown. This is the Lagrange interpolation formula. Let me see one example problem based on Lagrange's formula. F of x is equal to x minus x1, x minus x2, still till x minus xn divided by x naught minus x1, x naught minus x2 goes on x naught minus xn into y naught plus x minus x naught, x minus x2 till x minus xn divided by x minus x naught, x1 minus x2 still x1 minus xn into x1 plus x minus x naught, x minus x1 goes on x minus xn minus 1 divided by xn minus x naught, xn minus x1 till xn minus x1 into minus into yn. Now given x naught is equal to 0, x1 is equal to 1, x2 is equal to 2, x3 is equal to 4, x4 is equal to 5, x5 is equal to 6, y naught is equal to 1, y1 is equal to 14, y2 is equal to 15, y3 is equal to 5, y4 is equal to 6, y5 is equal to 9, and putting x is equal to 3 and substituting the above value in Lagrange's formula, we should find f of 3. Now we have substituted the values in Lagrange's interference formula, and last we get 1 minus 6 plus 15 is equal to 10. Thank you.